Hi guys, welcome to week 3 of NTI. Excuse me. Let's get through this week and enjoy a spring break. All right, this has been tough on everybody. We got 2 topics to do today with circles. The first is the area of a sector in a circle. A sector is going to be just basically a piece of pie, right? Right? It's going to be connected to the midpoint of the circle, right? And it can be any shape. Actually, you look at this and the first thing you think that that this is a sector, but really when you get down to it, this whole thing through here is a sector too, right? So today we're just going to talk about calculating the area of a sector of a circle. All right, here we've got an angle. It's a 90-degree angle, and it's a sector. All right, it's got a radius of 8, and like all right angles, it's 90 degrees. So the formula for figuring out the area of a sector is central angle divided by 360 times area. All right, let's do the math on this one. Central area is 90. Central angle is 90 divided by 360 times the area of a circle. I'm hoping everybody knows this, but just in case, it's pi r squared. So pi r is 8 and we square it. All right, we do the math on this, we're going to get 0.25. All right, 90 divided by 360 is 0.25 times pi r squared. To get this right, the first thing you need to do is to square the radius, r squared. So you're going to have pi, 8 times 8 is 64. All right, bring this down again, 0.25 times, you can put this straight into your calculator. Okay, pi times 64 is going to give you 201.06. Probably have to turn your calculator sideways to get the pi button. I don't think the regular calculator has the pi. All right, so now you finish off 0.25 times 201.06, you get 50.27. So it's straightforward. Central angle divided by 360, all right, times the area. And remember, area of a circle, if you want to put this in your notes, if you've forgotten, it's just pi r squared, where you do the math on the r squared first. All right, I only plan on doing 2 of these kinds of problems because since we got 2 topics to cover today. All right, look down your paper. You've got this written down. Central angle over 360. The central angle is going to be 100 over 360. This is times, okay, the area of the circle. All right, pi r squared. So pi never changes. R this time is 10, and we square it. All right, now we just do the math on it. 100 divided by 360 is going to give you 0.277, we'll call it another 7, times, all right, pi times r squared. R squared, we're going to do the r squared first. That's 100. 10 squared is 100. We bring this down, we get 0.2777. Pi times 100, put that in your calculator. It's going to be 314.159. And I'm going to put this straight in my calculator. I'm going to round this off. It's 87.24. Delta Math asks you to round it off to the 100ths. So I'm going to give you all a few extra tries because I don't want rounding to be an issue on this. So I'm going to give you extra tries just in case your rounding's off. All right, our next topic is intersection of chords. A chord is any straight line that touches a curve on the curve. Okay? Both ends of this straight line are on the curve. Our chords are just going to be circles. Okay? So it touches the end, each end of the straight line touches the circle. That makes this a chord. All right? We're going to do the length of intersecting chords. And I'm pretty sure y'all have seen this on your CERT test or ACT test, whichever ones you've taken. All right, on this one, let's call this X. This segment is 10. This short segment here is 5. And this segment is 4. All right, they want us to find X. All right, the formula for this is A times B equals C times D. On this one, that just means 4 times 10 equals 5 times X. Right? AB is a straight line, CD is a straight line. So this is going to be 40. This is going to be 5X. We divide both sides by 5. We get 8 equals X. All right. The one thing I want you to notice, especially this is true about my drawing, but it's going to be true off the drawings in Delta Math too. Don't go just by the looks. All right. Make sure that the math supports it. Sometimes it looks like a number should be bigger or smaller, but like I said, be careful. It's always going to be proportional, and the drawings doesn't match the numbers. All right, what I just said about forget about what the looks, just go with the numbers. This is definitely obvious on this one. This one, I've got 2 chords inside a circle. One is the length 36 and 2. The other one is X and 6. All right. They want us to solve for X. All right. A times B equals C times D. So A times B is going to be 36 times 2 equals 6 times X. Straight line. 32 times 2 is this line here. And 6 times X is this line here. All right, do the math on that. I get 72. 36 times 2 is 72. 6 times X is 6X. Divide both sides by 6. You get 12 equals X. All right, this should be a pretty decent math today. Not sure if we're having 2 or 3 lessons this week. If you don't find anything on Wednesday, just check back again on Thursday. All right, this lesson should be fairly easy, but it's going to take you a little while with the rounding, so take your time with it. If you have any problems, give me a shout. I don't care. Email, catch me on Remind. Email me and tell me you want me to give you a call. All those are options. All right, guys, have a good day.